everyone, welcome back to the channel. So today we are going to solve the shortest subarray with sum at least k. So we should directly start with examples which LeetCode has given. Then we will understand with the better examples that why 2-pointer here not work, because understanding the why that something is not working in this question is very important rather than jumping directly to the solution. And we are going to understand it with very good examples. We will take very good examples and we would dry run it, so it would get extremely clear in your head that why something is not working. So let's take first very basic example, then we would start with good examples. So this example is given by LeetCode, and if we take I and j here, and let's suppose I am taking answer first equals to 0, then first we get 2, then we take I here, then we will get 1, then I here, and we will get 3. So we got this sub array and we have to return the shortest one. So first we got the length as 3, and now we will find that other anything is possible or not. So we would subtract this from here, and we would get 1, then we will be here. So here the -1 is there. So mostly the cases where the positive integers are there, we would 2 pointers is easily applicable mostly. But here what if this negative numbers come? So here what we have to do, because it is decreasing our sum, so I would say that we could take it as a positive, because when we get here we only have 2, so I will take is 2 and j will be here, then both will go out of bound and k is not greater than anywhere, last is 2. So we get length as a 3, right? Let's take one good example, one more. Let's suppose we have nums our array as 54 minus 5, then 53, and we have, let's take minus 19 as well, and we should take 85, and let's suppose we have k equals to 119. So if we start as answer equals to 0 and our I pointer is there and j pointer is there, so we will take 54, then our I goes here, then we will have 49, then again I will go here, and then we have total equals to 102, and then we have to reduce the 19 and I will be here, and we will get 83. Then of course we will do 83 plus 85, it will be greater. So if I goes here, then we will have 168 as a last. So our j is at here and I is at last place, and 168 is obviously greater than 119, so our length is 5. Now we should start shrinking the window, because we want the shortest window, so we would take our j here. So before taking the j here, we have to subtract this sum. So when we will subtract this 54, our sum would come to 114, right? So our j is at second place, index 1, and I is at this place. So I'm changing the color. Now this thing has reduced our sum here, so we would not subtract 5 and we will get 109 as answer. It should increase our sum. Perfect. So it is I am adding 5 to 8, so we will get 119 and j would be here. So this is our new length, and 119 is greater than or equals to 119. So can I say that instead of 5 we have this our length, and when we reduce this 53 from 119, our answer would be 66, and j will come here. Then we would add 19 to it, then we will have 85, right? Then we would we had 119, then we have subtracted 53, so yes, we have 66. Then we are adding 19 to it, so 66 plus 19 we have 85. Then here j will be there, and we would subtract if 85, then we would get 0, and both will be go out of bound, right? So you are thinking that yeah, we could got this answer by adding the negative values and subtracting the positive values as we go to the left to right and shrinking the window. But I have one counter example as well. Let's suppose our nums is this -43, 97, 96, and here is the important part of the video. If you want to understand properly this question, please focus on this. So we have our answer as 0, so our I and j is here. So first we have taken -43, so our answer would go to -43. So when we do addition of 97 to it, we would get 54 as a answer. Now our I will goes here, and we will take 96 plus 40, 54, then we will get 150 as an answer. So we get this window, right? So what do you think our length will be? Yes, of course 3. So our window is big, we have to start shrinking. So we would shrink j to here at 97. So again our sum would increase by 43 because it has decreased our sum previously. So 193, right? So our length would be 2 because j is here and I is here, right? Still our answer is bigger than 97. So again we shrink, and our I is here, and we will get j as here. So if we subtract 97 from this, we would get of course 96 because I and j both are here. Now if I do I here, then we would add 97 plus 87, still our length remain same, right? Because it is of course greater than 97, sum of both. So if I remove this, let's suppose what is 96 plus 87, so we would have 183 here, but length is same because our I and j is here. Then if I subtract 96, then we will only have 87, and I and j is here again, but I and j is not greater than 97, then we would get I as here. Then again 80, 167 we would get, it is greater than, so I would check j is here, and we only have 80. So at last we are getting this length, right, which is 2, but our answer is correct or not? Of course our answer is wrong because we have 97 here, which is greater than or equals to 97. So our length should be 1, but we forgot it and we missed it in this thing. So hope you understood that 2 pointers will not work here. But someone would say that can we use the cadence algorithm logic? Some of you might know this algorithm, that when our sum goes in negative order, we would remove it. Now. So our example was that nums equals to minus 43, 97, 96, 87, 80 and k equals to 97. So when our I and j was here and answer goes minus 43 and I goes at 97th place, this minus 43 is contributing towards the k. Is it increasing our sum or decreasing? So can I say if our answer goes negative anytime, we would take it as a 0 and we could skip whatever the thing is there and we would take j as here, and again our sum would go 97 when I goes here, like I and j. So our 97 is greater than or equals to 97 and we got the length as 1. So is it the correct solution again or not? Because we have added this condition that whenever sum goes negative, we should get our j pointer to I pointer, right, like this. But what if I told you that I have one more example to counter it? Let's suppose we have this question and we have k equals to 3. So our answer is, let's take I and j as here and answer is 0. So 2, then our I goes here, then minus 1 as 1, then I goes here, then again we got 2, our I goes at 4th index, then we had got the 4 is greater than or equals to 3, so we got our window. So length equals to 4, right? Now we have to shrink this window because our answer is greater than k, which we do. So when we shrink this window, let's take the eraser and show you the answer. So when we shrink this window, our j comes here, so we would take 2 and our I is here. Now shrink window is done because our now answer is less than k, so we would take our I as here and our answer goes to 0. Did you see that minus 1 and plus 1 is cancelling each other, this thing, and minus 2 and plus 2 is also cancelling each other. And what was the rule? That whenever answer goes to less than or equals to 0, we would take our j pointer at the last thing and I and j equals to here, and minus 2 is not possible and both goes outside of the window or the array. But our answer is correct, that we got the length as 4. Think about it. Our answer is correct? Of course not, because we are seeing that there is 1 and 2 at the second and third places, 0, 1, 2, 3, 4. So 1 and 2 is present, but our length is 4 instead of 2. Why? So you see that both of these examples are contradicting. If we add this condition, then also is a problem. If we don't, then also it is a problem. So then we have to think out of the box that what other things could we use in this question. So we have seen that the sliding window thing, which was we are doing that, taking the windows and using the 2 pointers for it, was not working. So can we think about anything other else, like our window solution was getting wrong? So what could we think? Like, there is one thing, like if we know that beforehand what will be the sum, can we do something about it? Let's check. If windows are not giving proper sum, then if we know that beforehand what was our answer, can we do something? Let's try it. Let's say first we get 2, then we get here 1, then 2, then here 4 and 2. So we are saying that if we are at second position, let's suppose 2, our I pointer is here, and let's suppose our j pointer is here. So if I say that prefix of I minus prefix of j was giving me proper answer, then it could be a valid window. So let's check. 2 minus 2, it is greater than 0. No. Then we could take j here, then again do 2 minus 1 is greater than 3. So both are not possible. Then I and j, of course it would be not possible. 2 minus 2 not equal, greater than or equals to 3. So again, if we check at another position, like can I say that my I is here and j is here, and we could traverse like this. So prefix of I minus prefix of j, it is greater than or equals to k or not. So 4 minus 2 is greater than k or not. So 2 is greater than or equals to 3, not. Then again if I take j here, then we could say that 4 minus 1 is greater than or equals to 0. So yes, we got our window. And what are the indexes? It is 0, 1, 2, 3, 4. So we could say that at third index, these are indexes, right? 3 minus 1 equals to 2. So our window size is 2. But this condition, focus on this condition. This condition could take us to of n square, because every time we stay at particular index, so we are traversing that index into, let's suppose we are there, then we traverse 1. Then when we are at j, we would traverse this and this. When we are at this, then we traverse 2, 1 and 2. When we are at 4, then we traverse this and this. And let's take this also, but it does not matter because it will give itself 0. So we are saying that almost we are traversing like near the half loop. If you do the dry run, then you would know that we are traversing the half of the time, right? So sometimes it will be 3, then 4. So it will give us of n by 2. So nearly our answer would be getting again of n square. So it is brute force solution, you could say that we are taking every subset and finding. So it will not work. Then what will we think about? That prefix sum is helping us, but could we improve something in this? So whenever this type of problem comes, when prefix sum is working and something we have to think about, then okay, let's give here a blank and let's do one dry run, that what is the flow we could go in. So our first answer was suppose at okay, let's remove this, and in the starting we have our answer as 0, right? So our answer was, let's suppose 0, then it increases to 2. You got to see this here, that our answer got increases. Let me write the prefix sums as well. 2 1 1, then 2, then 4, then 2. So it is our array and it is prefix sum. So we have traversed this, then we got to 2, then again our answer got decreases, or not that much decreases. Let's suppose we are at 0, then our answer increases to 2, then again dip will come, then we are at 1, then our again answer was increasing. Do you see? We again catch up to 2, then again our answer was get increased by 4, then again dip was come, right? So at least we are at 3 times at the second position. Did you see? So can we observing something that whenever there is a dip coming, like whenever we are going down in the answer, there is certain point that our answer get increases at least to that position or before that. So can we think something like, if we take something as a stack q or dq, we would mostly take in this types of question dq, because we can do the operations from the front side as well as back side in the dq. So let's suppose we are taking one dq, and this graph is very important. And okay, I would again write the array, and let's suppose we have our prefix sum ready beforehand, right? 2 1 2 4 and 2. So we have our prefix array with our self. So we got to this point first 0, but our dq is empty, so nothing here to compare, so we would just insert 0, then we would go to first index, right? 2. So our answer is 2, right, currently, and we are at index 1. Let me write the indexes also, so we could get it. So these are the indexes. So our 2 is greater than 0 or not. So we are in increasing order, right? So we are going in increasing order, so we don't have problem. 2, right? And by going this way, we are also checking that 2 minus 0 would be giving us 3 or not. So here we did not get, so we pass this thing. Now we are at this position, I am using the red marker, 1. So focus on this thing, that now we came to 1 and there is a dip coming here at 1. So we would check, right? We will check that 1 is greater than or equals to 2 or not. So it is, did you know cadence algorithm we have talked about in the previous session as well, like whenever our things go in negative direction we try to remove it. Same you could think about here as well. So 2 is getting ourselves in negative direction, so why did not we remove it? so we would remove 2 from here. So this condition got checked. Then we again check 1 is greater than or equals to 0. Yes, it is. So we would take 1 here, right? And yes, we are taking the indexes here. So I should take here indexes, not the values. So it was first here 1, then 2, and we are removing this 1. Now again we reached at third index, this one. Now we check 2 is greater than or equals to 2 or not. So it is satisfying the condition. We would reach at third index, and we comparing also that our 3 the third index, like 2 is greater than 2 minus 0 is greater than or equals to 3 or not, because our goal is to reach third by going in the increasing direction. So I have taken this third index, means this 2 and the last one 0. 3 minus 2 minus 0 is greater than or equals to 3 or not. Now we reach at the fourth index. So now focus on this. We reach at the fourth index. Now we are at the fourth index. Let me take the white color, and I have inserted. So we are checking the 4 is greater than or equals to 2 or not, because previous index check this one. So it is satisfying the condition, that's why we have added here. Now after the insertion, we will check that 4 minus this, I would write properly like prefix of 4 minus prefix of 0 is greater than or equals to k or not. So 4 minus 0 is greater than 3. Of course it is satisfying the condition. Then we would store it in our answer, that we are taking int max, and we are removing, and we got the length as 4. Now we try to shrink the window. So here comes the important part. This condition is satisfying, so we try to shrink the window. Now remove this 0, and we will come to this portion, right? So this part goes down, and we pointed to. Now prefix of 4 minus prefix of 2 is greater than or equals to k or not. So check, prefix of 4 is 4 and prefix of 2 is 1, right? So we are checking this condition, and it is also satisfying our condition. So 4 minus 2 would be 2. So our new length was got V as 2. Now again we try to shrink the window, and we come to this portion. So do you check that by DQ we are shrinking the window, and we are going on the increasing direction always. So that's what the new thing here. Now we are again check that prefix of 4 minus prefix of 3 is greater than or equals to k or not. So 4 minus, what is that, 2. Which is not following the condition, so our length remains 2. Okay, no, so now I am removing the unnecessary things to make the things look little bit okay. Now we reach at the last index. I have taken the very good example so that you could know this graph and understand properly like why we are taking these things. So when we have reached 2, now check that this 2 is greater than or equals to 4 or not. So after 4 we are getting again deep, so we know that at some point we would reach at good point, right? So we remove this 4. Now again check that this 2 is greater than or equals to 2 or not. Yes, it is equals to, then why would we take this index? Like we could take this index. So we have inserted 5 and we goes out of the loop. Now we got our answer as 2 by this method. So let's write the pseudocode of it, and first we would take the nums, and we have to take the prefix array. So I would take long because the integer plus integer plus integer could exceed sometimes the sum of the integers. So we would take the long and let's say prefix and n plus 1 and 0, because we are considering 0 in this prefix, so length would be 6 here, right? We would take answer as an int max because we want the minimum answer, so we would take the highest, then we would find the minimum. Then normally we would find our prefix sum easily. So prefix sum of I plus j, don't be here confused why we are taking the I plus 1, you should know now what is the condition we are taking here. Prefix of I plus 1, did you remember our array was starting at like this, 2 minus 1 1 2 and minus 2 our array, and we are taking prefix sum as 0, then 2, then 1. So where did this 2 come? So it is at index first, right? So everything was 0 0 0 0 here, then this 0 we needed, so we have started this from here. So we are adding prefix 0, this prefix plus this 2, so we are taking this 2 and adding it here. So instead of this 0 we are taking 2. Hope you got this thing. And now let's move to another part. Now we are traversing on the prefix array as we have done here, like traversing the prefix array from left to right. So let's traverse for loop I equals to 0 till n, and here means less than or equals to n because n size is 5, so 0 1 2 3 4 5, total we are traversing 6 times. So first we check one condition, that our deque is not empty, then we could do some operations on it. If it is empty we cannot do anything, and we should just insert the element. We should just insert the elements in the deque, right? So I would take first here we would find to minimum length. So how are we doing the minimum length finding? We would check that prefix of I minus, did you remember from the front side we are checking dq dot front, and we are checking it is greater than or equals to k or not. I hope you remember the condition that at this 4 we have, at this point we have checked that in the front how many elements are there and what was its index, and we have taken this condition. Then we have taken this condition after removing this 0. So I have write this same thing from the front to our current index, and we will update our answer, and this is the main part. So I will write this like mean answer minus I minus dq dot front. Remember we got the answer as this 4 minus 0, then we get our answer by 4 minus second index, then 2 and 4, and we are popping and shrinking our window. So dq dot pop from front. So we are shrinking the window and it has been done. Now we have to think about one more case. While our queue is not empty, dq and which is this case, we should pop elements from dq or not. We are checking this condition that either should graph is decreasing or increasing. By this thing we are taking the decision of popping the elements from this queue or not. Whenever our graph was like this 2, then 1 we have popped something, if you remember, right? So by removing 2 we got our graph as again increasing because we have removed this 2. Okay, I hope you understood these things. So I would write that condition that if dq dot, we are checking from the this thing would come in prefix of dq dot back if it is greater than prefix of current, then we would do the pop. Then we would do dq dot pop back. Remember we have removed the 2, right? We could do also equals to as well because it will be easy, so we could here remove this thing as well. If neither of the condition are meeting, then we would it is a dq, then we should push in the back at the index and we would return our answer. If it is not updated anytime, then we would return int max. If it is not updating, then we would return the -1. We would check, it is a question mark here, would check, else we would return our answer. So if this thing was true, then we would return -1, else we would return answer. So this is the code, and I hope you understood whole logic of why we are not taking the sliding window, why prefix sum was not working, and why we have come to this monotonic Q and on those topics, monotonic DQ and this. So I hope you understood the logic and the question. Please do 2-3 dry runs so you could understand the logic and everything in the correct manner. And here the time complexity would be of course off, and then if you consider the space extra, it will be off, and for the prefix sum array. So if you